This video is part of the remote class for October 23rd. For tonight, we're continuing to explore spatial analytical tools, that allow us to create new geometries by combining existing ones, to repair and modify certain geometries, and then later on in this session to use different geometries to sort of summarize what's going on, where they overlap or contain others. Keeping on the sort of theme from the last video about merge, right? How you take a shapefile that's been fractured or multiple shapefiles that belong together and combine them. I wanted to show a couple of other key tools that are in the data management toolbar that are just really useful at sort of creating new geometries from existing ones. And the two that I want to talk about, the first is in data management features, and it's called feature to point. And notice that it has sort of cousins, right? It's got polygon, feature to polygon, and feature to line. And so, what I'll show you with the point can also be done with the others, right? You could take a polygon and turn it to just the lines. You could take a series of lines that join one another and turn it into a polygon. You can move between the various kinds of geometric data that we have. But a really commonly used one is this feature to point, and it's super freaking simple. And its entire purpose is that you take what is a polygon, something that you only need, or sorry, not only, something that you need to know the area and the shape of something, and turn it instead to just the point, right? A central point that stands in for that thing. And so if I were to run it here, and give it a second to sort of come back to me, it'll come back as just a point. Now, why would you need to do that? Well, some of the things, haven't really made themselves evident quite yet. But a little bit later today, when we'll start summarizing things and using spatial join, you might find that having a central point to be the thing that you select and contain can be really, really helpful. Right? If I'm maybe trying to summarize everything that's going on in this L-shaped area here, what if I have a geography that only overlaps this small angle here? Should I summarize it? Well, having that central point can be interesting because you'd be saying like only select or only summarize, that area where you can find a centroid. It's also a valuable tool in a few weeks when we get to density and interpolation. When we start actually looking to create heat maps and such, you'll find that you can only do those with points and lines. And so this ability to move between what was a shapefile polygon to a shapefile point is really valuable. Also notice here, if I open the merge feature to point, the attributes are all the same. So it really has taken just the geometry and gotten rid of it, translated and appended the attributes to a point shapefile instead. So useful tool. You'll find reasons for it sort of throughout the semester, but I want to make sure you have it. The other sort of interesting tool that hangs out in there, and I'm going to use this random point shapefile to show it, is called minimum bounding geometry. It's a really neat one that is often used when you have a series of discrete points or other shapes, and you want to visually create a polygon that surrounds them. Right? So it's a tool that lets you take a series of inputs and draw the smallest possible geometry that would contain all of those things. So I will, drag in my random points. And, really the main thing to do here is, pick a shape, first of all. So, one will draw a rectangle. The other will draw a convex hole. One will draw a circle. I think circle and convex hole are probably the two I want to show you. A convex hole will literally just try to create the smallest possible shape it can, as long as sort of it has one of its edges touching one of the points. This point about group, don't even worry about it. Just keep that all for now. And we'll hit run. It'll take a second to do its thing. Right, and here you move from a series of kind of random shapes. Perhaps they're incidences, or maybe they're sort of places where, people live or where I do things. And what I want to create is sort of the area where that happens in. And so that's what we create here, right? A convex hole that sort of surrounds them in such a way where the vertices are ultimately touching. The same thing, or similar if I wanted to do a circle, maybe I'll call you circle. It'll draw the smallest possible circle it can that'll contain itself around those shapes. So again, this is when you usually want to move from looking at like a cluster of things, usually points, and quickly visualizing and getting the area that would contain those points, right? How big a circle would you have to draw to contain all of your things, right? What's the total radius in which a series of events happens? This is the tool that you would use to create that. So these aren't tools that you may use every day, but they're critical ones. And I suggest those who are finding them interesting really explore this features tool set a little more. We've been here without even realizing we've been here, right? We've added XY coordinates. We've copied over features from one thing to another, right? There's a lot of cool little ways to modify geometry in here, but really that feature to point and minimum bounding geometry are definitely the two most useful ones that you may pull out of your hat from time to time.